Radiology, Tirthankar Mahavir University, and in association with Institutional Innovation Council and Indian Academy of Oral Medicine Radiology. And today's topic is Artificial Intelligence in Dentistry, Current Applications and Future Perspectives. And on this occasion, I welcome our Principal, Sir, Dr. Manish Goel, to say a few words on this occasion. So I welcome you, sir.
Very good afternoon to all of you. I'm sure I'm audible.
Yes,
right?
sir, you're yes, sir, you're audible, sir.
Okay, so kindly excuse if the connection is cut in between because I'm traveling. But anyhow, first and foremost, I would like to welcome all the participants who have shown the interest in this particular topic, artificial intelligence. And why not? What I feel today is the world today has become more of a materialistic world, and it wouldn't be wrong if I say that it is an artificial kind of a world. And to deal with this world, you really need a lot of intelligence. And Dr. Sridevi, I welcome you to this platform. And I'm sure you are going to impart all your probable knowledge to all our participants today on this platform. Coming to Dr. Sunil, what should I say about him? He is like a front soldier, I should say now, in this period, who has always come forward to conduct all these CD programs.
Hello, sir, you break in audible, sir. I think there is a network issue. Thank you, sir, for kind words. And I welcome our IMR President, Dr. Vinay Kumar Reddy, the Professor and Head, Department of Oral Medicine Radiology, and is a Mamata Dental College, Khammam, Telangana. He is the President of Indian Academy of Oral Medicine Radiology. I welcome you, sir, and kindly say a few words on this occasion. Thank you for us for giving an opportunity to associate with our IOMR, with our university.
Thank you, and good afternoon. Good afternoon. And to start with, I'm very happy that Tirthankar Mahavir University and Tirthankar Mahavir Dental College and Research Institute, in association with IOMR, is conducting an online CD program as a part of IOMR Day. So IOMR Day happens to be on 24th of April, but already the celebrations have started, and in the form of online CD program, webinars, and all over India colleges are conducting many programs. And Sunil is my senior in college during my post-graduation, so he's very close and he's a very close colleague. And also thank Dr. Manish Goel, sir, for giving Dr. Sunil an opportunity to conduct the CD program, because without which it would not have happened. And I also thank the other faculty members of Oral Medicine Radiology Department in your college for coming forward and conducting such a program. And also all the participating members, definitely you will go with a lot of knowledge. As sir was telling, artificial intelligence is very important as of now, because everything is artificial. Thank you, sir. Thank you, Manish Goel, sir. And last but not least, I also thank Dr. Sridevi, my member in IOMR Association, as well as a very good colleague of mine. So from the same place, Andhra Pradesh. So Professor and Head of Lenora Institute of Medical Sciences, for coming forward to give a nice lecture on artificial intelligence. And thank you, and thank you all for making this happen. So thank you for inviting me.
Thank you so much, Dr. Vinay, and thank you for your kind words and supportive. And you have been always be supportive to me, but in all these programs we have been organized by our university. Now, our today's speaker, a well-known, eminent personality in India, and she is none other than Dr. K. Sridevi. She is a professor and head of the department, and she is a PhD guy, Department of Oral Medicine Radiology, Research Director at Lenora Institute of Dental Sciences, Rajahmundry, Andhra Pradesh. The madam has finished her graduation and post-graduation and in the subject of Oral Medicine Radiology in 2003 from Government Dental College, NDR University, Andhra Pradesh. And now she is holding the position. She is to credit, has many publications as well as she is presently Joint Secretary of our association. And I welcome you, ma'am, on this forum to be a part of this. And kindly, of course, definitely your lecture today will enrich to all the delegates who have been attended. And I think this time we covered about 5 states from various parts of the country to be remarked as a national program. And many people, all the undergraduates and postgraduates and the faculty members have been added up in the group to waiting for this particular topic on artificial intelligence. Over to you, madam.
Thank you, sir. Thank you, Dr. Sunil, sir, Dr. Vinay, sir, and for your kind introduction. And I also my due regards to the IOMR fraternity.
Ma'am, you can share the screen and
yes, but no, here you cannot share the screen.
Yes.
Is my screen visible, sir?
Yes, ma'am. Yes, visible.
Yeah.
No, ma'am. You have to change. We're not visible.
Oh. Share screen.
Yes, ma'am. It is visible.
Yeah.
It is visible. Okay.
Thank you, Sunil, sir, for your wonderful introduction, and respected principal, the President IOMR, Dr. Vinay Kumar, sir, and my dear colleagues and students of Tirthankar Mahavir Dental College and Research Center and Lenora Institute of Dental Sciences, and other colleges, other students from other states as well. Very good afternoon to you all. As mentioned earlier, I currently work at Lenora Institute of Dental Sciences, the one right now on the screen. And today I would like to throw some light on current applications and future perspectives of artificial intelligence in dentistry. And these are my contents. What is AI? As everybody knows, the term artificial intelligence refers to the idea of machines being capable of performing the human tasks. In other words, the term AI is applied when a device mimics the creative functions, cognitive functions such as the learning and the problem solving. So how is it affecting in our day-to-day lives? Whether we realize it or not, AI is all around day-to-day life, right from starting our, when we open our Facebook's news feed, and every time we we do a Google search, and when we book a ticket trip online, and AI is lurking in the background. And when it comes to the virtual assistants and also the healthcare management, especially in disease mapping, personal healthcare, and e-commerce chatbots, and email spam filters, and natural language processing tools. And more fascinating is the self-driven, driverless self-driven cars, and our AI robotics, more fascinating, and AI-powered robotics, right from working on the assembly lines at Tesla to teaching English to students, Japanese students, all is about AI. How AI has started, everyone who's using the Apple, what is Siri doing? Siri is answering every question that you ask. How does Siri is doing it? How does Siri know about you? Siri is answering everything you ask. And after talking to Siri for 6 months, you can see that she will be talking to you more and more fluently and more understandingly. How Uber is knowing where are you, and how you get to know the location right now, and we all must be using Netflix like anything. How Netflix gets to know about you, what is good for us, and what we would like to see. whenever we going to search something on Google, when we type few words, then 10 things will, or 10 different options will pop up. How does the Google know about it? Everything is about AI. So see, when we, the news has been spread that the webinar is on AI, even the city has come to virtually participate the webinar. Just
What
have
is the weather today?
Can you kindly mute yourself? Now you can unmute yourself and you can start.
Oh, actually, I wanted the video to be played, sir.
Okay, I think you have to minimize and do it now.
Right now, the video is also not audible, sir.
Oh, video is not there right now.
Oh, it is not there on the screen.
No, it's not there on the screen.
Now?
No.
Is it audible, sir, video?
No, madam.
No.
No, not audible.
Oh, 1 second. But here you are sharing your screen. I'm able to see this message, but I'm not able to. My screen is not.
No, madam. This video is not there.
So what is there on the screen right now?
It is showing something that Amazon Alaska speaker. That's all.
Yes, but the voice is not audible, sir. Actually, I wanted to show that only. The
Maybe you can-
voice, a male voice.
No, I don't think so. Voice. Video.
Is it audible now, sir? No.
No.
Okay, I just skip the video then, sir.
Yeah, definitely.
So coming to the history of artificial intelligence, it is the credit has been given to Alan Turing, an young polymath British citizen who has given his lectures in 1947 on artificial intelligence at the London Mathematical Society. He devised a test called as a Turing's test. Turing's test, where the human questionnaire asks a series of questions to both the participants. 1 second, sir. After a specified time, the questionnaire tries to decide which terminal has been operated by the human respondent and which terminal has been operated by the computer. And here, he wanted to say that during the Turing the machines can learn from the available knowledge and perform the tasks. So there's something there on my screen. 1 second. Yeah. Next, however, the visionary cognitive scientist who co-founded the advances in the emerging discipline of artificial intelligence, the credit goes to John McCarthy, who coined the term artificial intelligence in 1956 and is considered as father of artificial intelligence. He defined the word artificial intelligence as the field of science and engineering concerned with the computational understanding of what is commonly called the intelligent behavior and with the creation of artifacts that exhibit such behavior. There are some milestones in the development of artificial dentistry. artificial intelligence, sorry. Artificial neurons were invented in 1943, and whereas the introduction of the neural networks in 1956. However, these artificial intelligence based the periods of winter, like where the expectations did not meet the outcomes of the results of the experiments done on artificial intelligence. But during the last decade, the actual interest in the artificial land expectations on the our technology were not met by the actual has grown ever before, and in the field of artificial dentistry intelligence. For instance, the textual output of the state-of-the-art natural language models became so convincing that the readers cannot distinguish between the human written and artificially generated texts. After that, the face recognition became so proficient that the technology's potential to affect the civil liberties and caused the activists and watchdog groups and lawmakers to act upon it. That means AI has shifted from fantasy to reality through its impact on the society, economics, and politics, and where the healthcare is no exception for it. And there are some basic terminologies and key aspects of artificial dentistry. And these, at dental point of view, as a healthcare worker, in the initial stages, the basic terminologies and the key aspects of artificial intelligence go hand in hand. The key aspects, what are the components of artificial intelligence? You have two components called as the machine learning and the deep learning. Here, the machine learning machine reads or scans the intrinsic statistical patterns of the data that is being exposed to it, and it draws predictions on the unseen data. That means that you have to feed machine learning, artificial intelligence in dentistry. For us, it is all based on the software and computers. For that, certain algorithms need to be created based on the data that is being fed to the systems. This data is being fed by the clinical experts, be the maybe the oral physicians or the dental experts or the medical experts, and later comes the role of an engineer, where they create algorithms based on the data we feed to the computer, and based on the algorithms, the data will be trained and algorithms are created. Then the testing data should be fed, and the outcomes are to be predicted, where you may have some errors. So when you have to repeatedly feed the data to the system, the more the data, the lesser will be the errors, and the more accurate will be the outcome. I think the concept is clear now. What actually artificial intelligence is, both machine learning and deep learning. These two are the subdomains of artificial intelligence, where you need to feed the data to the computers. The computer reads the data, and thereby algorithms are being created. That means in the form of sometimes the artificial neural networks, and this data is being tested for the outputs, and repeated exposure to the data will give you a more accurate outcomes. And the outcome testing data should be repeatedly tested, and based on it, you have a data set. Algorithms are tested, and when you export your radiograph or findings, say for example the radiographs or the OPGs or your photographs, clinical photographs or pictures of your histopathological pictures or whatever, the prepared crowns, and then the output will be generated, and it has again to be tested. Okay, these are the key aspects of the artificial intelligence. You have machine learning, you have deep learning. Machine learning as a simple task, it performs the simple tasks, and you have the different aspects of the machine learning in terms of classifications, in terms of dimensionality reductions, segregation, segmentations, semantic analysis, these terms, I'll be just telling what do you mean by all these terms in the consequent slides. And deep learning is a subdomain of machine learning, and hence the artificial domain, artificial intelligence. It functions through more complex layers, hidden layers or filters called as neural networks. Okay. So machine learning is the representation of intrinsic statistical patterns or structures in the data, which allows for predictions of unseen data. What does this mean? So you have to feed maybe the in terms of a cat or images of some animal, some images of objects. Maybe for humans, it is the intercanthal distance, it is the facial form, it is the contour of the profile kind of thing. That kind of features that you need to feed to the computer. Okay, based on the data that it has in the processing system, it will predict the unseen data. When you expose a fresh object, then it will tell whether it is a cat or dog, whether it is male or female or image. Maybe for the images, and if it is for mails or any content-based, whether it is emails, say for example, whether it is spam or ham kind of thing, that will detect. Okay, the machines will detect by learning the from the data that we feed. The machines will learn and they will interpret. That is the basic gist behind the artificial intelligence. So whatever we feed, that will the outcome will come. That is one thing. That is the machine learning, where you have simple algorithms will be there. Next, you have the machine learning. Okay, deep learning. Deep learning. Here the system learns from the data we feed, and it extracts some more concepts. Okay, that is the deep learning. The machine learning, they have different aspects like classification, regression, clustering, dimensionality reduction, ranking, and recommendations. These are a little complicated terminologies. AI systems are based on applied handicraft rules to the specific task that they were meant to solve. If you design a software or an algorithm to detect caries, if you feed or whatever you expose the radiograph, say if I'm taking a radiology as a basis, or a photograph to if you are taking a photograph, if you're asking it for the gender identification kind of thing, but age identification you have not made, you have not fed, that time it will only identify the gender, but not the age. It cannot identify, the system or the algorithm cannot identify the gender. Okay, it will age, it will only identify the gender. Okay, that's why whatever task you feed, that you can expect only that outcome related to that task. Okay, each task required domain specific knowledge, engineering, and manual fine tuning of the system by the subject matter experts. Finally, it's the subject matter expert, that is maybe in dentistry, it's the dental experts who should decide what should be the outcome depending upon the given data. Then the testing data will take its own path. Okay, next, machine learning invariably involves the parameter tuning with regards to underlying techniques such as the number of neurons, layers in the neural network, population size, selection strategy, and mutation rate. Typical machine learning tasks, what are the jobs to be performed by the machine learning means the classification. It predicts the class of an object, whether the object that has been fed, that means we upload the object to that particular software, is the image of a cat or dog from an image, a male or female from the user's web activity, spam or ham from an email content. Next, regression. It predicts the continuous value of an object. Sales, projected sales in the next month. How you can expect the sales in the next month based on the sales during the previous months. That is one kind, that machine learning can do that. But based on the previous sales during the previous months, considering that is one factor, and also anticipating the future circumstances, maybe like coronavirus, based on the machine learning will not consider the fact because of the pandemic. So it will not alter or it will not consider that while fixing up the sales during the next month. This is how the machine learning, the limitation, this could be one of the limitations of the machine learning. And price of the house with specific features. Again, here also the human abstract thinking cannot replace any machine. Okay. Next, you have clustering. Clustering is group similar objects together and find user groups different by their behavior on the site, cluster customers into meaningful groups, etc. These are another task of machine learning is dimensionality reduction. It compresses the data from high dimensional representation into a lower dimensional one that is useful for visualization or any other internal transformation for other machine learning algorithms. Here, if suppose your conversion of a spherical, that means a sphere, that means a three-dimensional object to a circle, a two-dimensional object. So that's how the dimensionality reduction. This is one more task that is performed by machine learning. And ranking. Arrange the list of objects to maximize some utility by clicking the probability or the relevance to a query. When you search for articles in PubMed, you may have these things, no? The objects to maximize your utility. You have some filters when you select certain types of filters, maybe of duration 5 years, or maybe of depending upon the filters that you select, no, the articles will get automatically rearranged, the data. Okay, next, recommendations. Filter a small subset of objects from a large collection and recommend them to the user. Increase sales and client loyalty, time spent on it, service and cross sale and upsales. Based on these things, system, the AI gives us the recommendations, like your YouTube. And next comes your deep learning. Deep learning is a subset of machine learning in which the multi-layered structures of algorithms called as artificial neural networks are trained to learn the features of complex data structures. Here, the difference between machine learning and deep learning is here. Machine learning is a subset of AI, and deep learning is another deep subset of or subdomain of the machine learning. Here you have a multi-layered structure of algorithms called as artificial neural networks. The functions, the tasks of deep learning are being achieved by artificial neural networks. Here, for machine learning also, you need to have an input and a neural network and an output. Here, the neural network in machine learning will be shallow, whereas in deep learning, the neural network, artificial neural network will be more complex, multi-layered neural network will be there. And next, you have artificial neural network. It is a structure composed of many small communicating units called as neurons, organized in layers, with the idea of making the machine to behave like a human being by constructing or by incorporating the structure similar to brain, okay, neurons. Here, deep learning has huge data needs. The amount of data that needs, like how we said discussed in the earlier, machine learning also needs some data to be fed. But here in deep learning, a huge data needs to be fed to the system. Okay. Deep learning has again more data. Deep learning, you have more data, and also you have neural network is more complex and more number of connecting layers. Again, another subset of this deep learning is filters will be there, where convolutional neural network, these filter some of the features of the features that we upload or feed to the computer. Okay, deep learning has more complex ways of connecting layers with more neuron count than other networks to express complex models with more computing power to train, and further has automatic extraction of the feature. A neural network is composed of an input layer, an output layer, and hidden layers in between. Okay, in deep learning, algorithm uses multiple layers to detect simple features like line, edge, texture, to complex shapes, lesions, whole organs, and hierarchical structures. That means the data, the weights, you call it other words, weights. The weights that we are carrying, we are feeding, the dental experts feeding to the system is in terms of a line. Suppose you are creating an algorithm, or you're creating a software for a periapical lesion. Okay, a periapical lesion, whether the periapical lesion is round, the line, or it is irregular or regular, whether how is the edge, the texture, whether it is smooth or not. You have to enter maybe 1,000 scans you may take. For all the 1,000 scans, you have to select some algorithm, like some features, weights in the form of weights, and these weights are needed to be noted and filled an Excel sheet, and that Excel sheet is to be fed to the system. Based on the system and the score, the engineers or the technical team will create algorithms. Okay, then they, after training this, they will pass, or they'll feed again. They'll upload some test data. If you go through your CBCT machines, there will be some test scans. Okay, these test scans to be repeatedly subjected to go through the training data, should be subjected to go through the test scans, so to improve the accuracy of the final outcome. See here, input neurons, output neurons. Here the hidden neuron. If it is more, may usually shallow neural network. Here it is more deep, used in deep learning. Okay, and here you have filters. It is the convolutional neural network. Shallow neural networks are composed of an input layer and few hidden layers and an output layer. A deep neural network have an input layer and multiple hidden layers are neural networks. See here, these are the neural networks and an output layer. And convolutional neural networks additionally have the filters. These convolutional neural networks use filters to scan a small neighborhood of the inputs. Okay, it's almost similar to it's a part of the deep neural network, for that matter, artificial neural network, and where you additionally you have filters. Okay, the example of deep learning with the application of detecting the caries using the radiographs. See, you already set one algorithm, you already have your software ready. Then the radiographs will be imported to the software. If it is IOPA or OBG or PyTwin, you have to incorporate import the image in the form of JPEG. If it is CBCT, you have to incorporate the import in the form of a DICOM image. So there are different softwares right now available, are Denti AI and DiagnoCat. These are some of the softwares. WebSep is another one. You have some more as and when it is required. I'll be just discussing with that. When you are importing the image into the software, the input layer, it reads by the input layer, hidden layer, and the output layer, and detects, applies this, whether if it is a carious lesion is there, the color coded will be applied, and non-carious lesion is usually red color is applied to carious lesions, and they have what they have stated in the literature that why red color is, that is a symbol for sacrifice. They have mentioned that means some issue, I mean a disease kind of thing. Okay. So the radiographs will be imported to the software as input layer. Through multiple hidden layers, the algorithms will classify the imported radiographs as carious or non-carious based on the AI training. Okay. So ultimately, the final outcome is based on what we feed the computer, what kind of algorithms we created. Okay, design. Next, there's one more term called as clinical decision support system, important in a healthcare field. Here, a clinical decision support system is any computer system designed to help the healthcare professionals to make clinical decisions through managing the clinical data or medical data. Here you have 4 components. One is the inference, has 4 basic components. Inference engine, which contains the data and the knowledge base. Whatever data we need is being stored in the knowledge base, and explanation module and working memory. Explanation module is not present in most of the softwares as on today. Inference engine is the main part of the clinical decision support system. It contains the knowledge about the patient from which to draw the conclusions regarding certain conditions. And the knowledge used by the inference engine is represented in the knowledge base, and it is stored in the knowledge base, and tools that have been created to facilitate the acquisition and elicitation of the knowledge. The collected patient data may be stored in a database that may exist in the form of a message and is known as working memory. See, in a simple language, inference data is whatever contains the knowledge about the patient from which to draw whatever the information. It is like similar to our history that we record, or findings that we record, the observations we made. So the conclusions will be drawn based on the observations that are being fed to the system, based on the case in question, and also the pre-existing. It learns, or it takes the inference from the pre-existing data that is being already fed. Okay, the knowledge used by the inference engine is represented in the knowledge bank that is there in the knowledge base, and the tools that have been created to facilitate the acquisition and elicitation of this knowledge. The collected patient data may be stored in a database and may exist in the form of a message and is known as working memory. See, this is the flow chart, inference engine and the knowledge base, bilateral flow of these two things, and that has been stored in the electronic medical record, and based on the medical knowledge in the database, and based on the information that we give to the system, or from the images that we upload or import, the information has been captured by the computers or the systems, and they allow, based on these things, the findings or the data that is there in the electronic medical record, the reporting system or the elicitation of the reporting of the findings, detection of the observations will be given in the form of an output. So this module, the working module, explanation module, is not present in all the clinical decision support systems. This module is responsible for composing justifications for the conclusions drawn by the inference engine in applying the knowledge in the knowledge base against the patient data in working memory. Yeah, artificial neural networks are highly interconnected network of computer processors that are inspired by the biological nervous system, that is the brain. Okay. So the ability to learn from the historical examples, from the previous experiences we can consider, and analyze the nonlinear data, handle imprecise information, and generalize, enabling the applications of the model to independent data has made them a very attractive analytical tool in healthcare field. These neural networks are applied in the clinical data evaluation, image analysis, in radiology and histopathology, and data interpretation in intensive care settings, and waveform analysis. This neural network consists of variable number of artificial neurons or nodes that are connected in hierarchical layers: an input layer, one or more hidden layers, and an output layer. Each node, with the exception of an input neuron, receives the multiple weighted inputs and produces an output that is usually nonlinear function of the inputs. A neural network learns through repeated adjustments of these weights. Weights are nothing but the features that we feed. Say, for example, again, how do we analyze these things? Is any image anything that you're feeding data will be in the form of a digital image. That digital image will have pixels. So that means each pixel, the system reads each pixel for its shape, for its maybe different shades of gray or different colors, and maybe radiolucent or radio opaque. How does the pulp appears? It is radiolucent, and how does the enamel appears? It is radio opaque. That's how we write these observations. The dental experts write these observations, make a note of these observations in an Excel sheet and feed it to the computer. But there are many shades from this 0 to 1, no? Radiolucent 0. If you give 0 to radiolucent, that is pulp, and enamel 1, radio opaque, there are a lot many shades of gray. Okay, so which one to analyze? The pixel, each value, some information should be given to the pixel regarding the gray values also. So that there comes the fuzzy logic. Okay. Recent advances in neural network. Recently, the advances in neural network are the convolutional neural networks for image classification challenges, and dilated convolutional neural networks for semantic scene segmentation challenges. These are mainly convolutional networks in the form of a UNet Excel is used in some of the research studies, and dilated convolutional networks are usually used to even in aiding the radiotherapy treatments also. The two main classes of the convolutional network neural networks prevail for volumetric prediction in general. There are two types, tiramisu and dilated convolutional neural networks data. And tiramisu based models such as the UNet excel at UNet. Tiramisu based models such as UNet, it excel at predicting the dose volumes that tend to be spatially consistent with respect to the anatomy, such as the dose volume to the prostate. And there's one using this UNet software, some OPGs were tested. There was a study conducted by KGMC Lucknow people also to evaluate the presence of the OPGs were evaluated for the caries and periodontal issues, and that was published. And dilated convolutional neural networks utilize convolutions that skip over the information during their encoding stage and help to extend their field of view. That means you have nodes of Ranvier kind of thing. See here, say for example, dilated convolutional network, dilated later on they will convolute. So the main intention here is to extend the field of view. Next horizon of these neuron convolutions is this. See here, this kind of thing. So the field of view, the reach is the extending. Okay. Dilated convolutional networks can also play a role in predicting the dose that can be mobile with respect to the anatomy, as in head and neck cancers patients, to predict the volumetric dose during the head and neck cancer radiotherapy, IMRT, intensity modulated radiotherapy. This would be another advance in artificial intelligence, planning the dose for IMRT. And next you have fuzzy logic. The fuzzy logic is a machine learning methodology that deals with the science of reasoning, thinking, inference, and recognizes and uses the real world phenomena that everything is a matter of degree. So there are many shades between black and white. Okay, gray. All the shades of gray are being integrated in fuzzy logic. Instead of assuming everything is black and white, conventional logic, fuzzy logic recognizes that in reality most things would fall somewhere in between, that is varying shades of gray. Say for example, selection of the shade guide, shade selection. So you just cannot have one shade or two shades. No, there are so many in between. Same thing happens with the grayness. Okay, radiolucency, radiopacity, mixed radiolucency, radiopacity. Just for the sake of understanding, I'm telling there are in many other fields will have such areas, gray areas. And the four major components of the fuzzy logic system are rule-based, falsification, inference engine, and defalsification. Okay. Next, you have another term known as evolutionary computation. Evolution based on evolution, the computerization based on evolution. Okay. So based on it was first introduced by Holland in 1975. This is mainly the Darwin, not neo-Darwin paradigm and classical Darwinian evolutionary theory mainly based on it. For us, in dentistry, it is the genetic algorithm that is more important for us. So this genetic algorithm helps to predict the population. It consists of the population generator and a selector, fitness estimator, and 3 genetic operators, namely the selection, mutation, and crossover. So based on this, you can identify the patient's population race who are at high risk of developing cancer. At the same time, or the canine impacted canine, the size of the impacted canine, and the surface loss. These things can be estimated with the help of a genetic algorithm and so many other things. Successfully, these genetic algorithms are applied in different disciplines like biology, medicine, and different branches of engineering. There's another system called hybrid intelligence system, which uses different algorithms together, and the genetic algorithms and artificial neural networks and fuzzy design. All these things can be utilized and can be applied. This is a synergistic system. It allows to extract the knowledge from raw data and to accommodate the common sense, to use human-like reasoning mechanisms and deal with uncertainty and imprecision, learn to adapt to a rapidly changing and unknown environment. And many different hybrid systems are available, and popular ones are artificial neural networks for designing fuzzy systems, and fuzzy systems for designing artificial neural networks, and genetic algorithms for automatically training and generating neural network architectures. The applications, now these are all the basic terminologies and about the artificial that you need to know, but there are a lot many more terminologies, and it is much more deeper than what we have discussed just now. And applications in dentistry. Coming to the applications in dentistry, before we go to the applications, we need to know about the softwares, different softwares that are in use as on today. DiagnoCAD, WebSEF, CEPEX, Denti AI, ExoCAD. DiagnoCAD is used to evaluate the CEF and IOPs, OPGs, and also CPCTs. And WebSEF is mainly for the supplementary analysis as well with the specs. Denti AI is also used for the supplementary analysis and evaluation of the periodontal issues, and carries OPGs, it evaluates, and the algorithms that you upload for CEF will be different, and if you upload the OPG, the algorithm would be different. And ExoCAD and 3ds CAD are the softwares used in CAD/CAM, especially in India. And NemoCEF is another one. Dental XRA, these are in still trials, and 3Shape, Foxit, and OneCEF, and CEF Ninja. Foxit and OneCEF are the apps, mobile apps, which will evaluate the cephalograms. So applications of dental artificial intelligence in dental education and research is this incorporation of AI in intelligent tutoring systems like Unified Medical Language System. What is this Unified Medical Language System? It is a combination of metathesaurus and semantic network and specialist lexicon. Here you have metathesaurus, you have different concepts, biomedical concepts of over 100 sources, and semantic network has it will be categorized, and this artificial network will draw the relationships between this between the concepts and the categories. Also, thereby language processing. Semantic network is nothing but understanding the meaning of a word or a language. Okay. So the incorporation of AI in intelligent tutoring systems like in the Unified Medical Language System resulted in huge improvement in the quality of the feedback that the preclinical virtual patient provides the students. That is like one NLM, National Licensed Medical Library, is one of such kind, UMLS. And artificial intelligence and patient management. Say, for example, with Sarah Simpson, I have taken these pictures from the net. She got her job like as a receptionist in a dental clinic based on her abilities as a enthusiasm of enjoying the communicating with the patients and her personal soft skills and all. But after 3 months, her frustrations enlisted her the learning to use the system, and also the tedious to manually follow up with the patient's appointments, and time consuming to manually check and send the reminders via WhatsApp, phone calls, and patients on their appointments. So what is the solution for this? She has been given a Connectify, which has the central calendar and centralized platform with remote access, streamlined patient management process, and automated work stream, comprising the central calendar, patient profile summary, and templates for messages and replies, and link for patient to fill the records, and automated patient waitlist. These things made her job more easy and more efficient, and saved a lot of time. Okay. So not only that, AI can also assist in coordinating with regular appointments and alerts the patients and dental healthcare workers about the checkups whenever any genetic or lifestyle information indicates increased susceptibility to dental diseases. In diabetes, as we all know, periodontal screening, but sometimes during our busy schedule, we may tend to forget asking these things. How important is this? Asking the history, but even if we skip this AI forewarns us regarding these things, and oral cancer screening for high risk population. Not only these things, many other things. And it can also create a database about any other relevant medical history or about any allergies that the patient may have. For instance, the AI can also build up a large data mine based on which we can draw many conclusions, and many observations can be made, and the research like unreported data. As on today, there is lots and lots of unreported data based on certain findings. But no, with the AI comes into the regular day-to-day practice, dental or medical health field, most of the data will get reported, or at least it will get recorded. Okay. And it can not only assist the clinical diagnosis and treatment, but also provides emergency tele-assistance in cases of dental emergencies when the dental healthcare professional cannot be contacted. Here, the dental virtual assistant when the dental surgeon is asking about the probe, the assistant, robotic assistant is giving him the probe. When he's asking to get the mouth mirror, this is the role of a dental assistant. Artificial neural networks work well in cases where the etiology of the disease is multifactorial. Say, for example, recurrent aphthous ulcer, the condition where the precise etiology is questionable for most of them, where it can be detected on the basis of its recurrence and by exclusion of other factors. Okay. Next, the AI is employed in screening and classifying the suspicious altered mucosa undergoing pre-malignant and malignant changes, and even minute changes at a single pixel level. That means a single change in a single cell also can be noticed, which is usually unnoticed by the naked eye and can be detected. AI might accurately predict the genetic predisposition for oral cancer for the larger population. And feature extraction, that is the machine learning, whereas the deep learning using artificial neural networks, based on this, but both can be clubbed. Okay. when we input this image, okay, radiographs, radio data is been fed to the computer, features are being extracted, and based on the machine learning, presence of cancer or not present. Okay, if cancer present, not present, and dysplasia, whether it is there or not, and it is normal. Okay, these are the things that can be, these are the applications of AI. AI in radiology, when a vast amount of data, patient data is recorded through digital IOPA or 3D scans, the AI aids to promptly gather and compute the data for the needful, made before the research or to plan for any dissertations or to plan for the treatment of that particular patient alone. Genetic algorithms and artificial neural networks are also useful in predicting the sizes of unerupted canines or premolars, and can also be standardized for predicting the surface tooth loss. In 3D radiographs, such as the tomography scans, the annotation of anatomical landmarks and segmentation of bone and teeth structures are achieved by AI. Nerve recognition and pathological identification are also possible with the algorithms. But what most of the algorithms that we use, the softwares that we use on CBCT nowadays are like, we have to do the nerve mapping and plan for the implants. But now there are certain softwares where the automatically plan for the implants. The DiagnoCAD is one of such kind, and this is effects that is supplementary analysis, and not you have to upload the image, then select the type of analysis that you want, and you calibrate the image, and then you have to upload this step, and then you have to calibrate, and segmentation and analysis you'll have. You get the report in no time. See here. And when integrated with the imaging methods like CT, MRI, CBCT, and MRI, it can identify even a minute deviation from normal, which remains unnoticed by the human eye. It takes a lot of time to go through, unless like gross abnormality, and by asking the clinical history, we may anyway we will not miss the pathology, gross pathology, but minor unnoticed changes also will be noticed by this AI. Okay, this machine learning algorithm can detect a lymph node in the head and neck image as normal or abnormal. How do we detect? It detects based upon the size. Okay, but that minor change in the size, again, it's the responsibility of the healthcare provider whether to consider it as normal or abnormal, but it detects that there is increase in the size. But it's you people, we people, who should use our common sense. And it aids to localize the apical phenomena, thereby magnifying the precision of working length of the determination of the radiographs. In identifying the proximal caries using techniques like object detection and semantic segmentation as one of the tasks by the machine learning. Okay. So next, it also detects the root caries or vertical root fracture in digital radiography, provided this root fracture earlier in the DiagnoCAD in India, that root fracture was not being fed. Okay, again, that features, that software features, whatever features that there have been inbuilt features that you need to know before you, if you plan to have one with you. Okay, and now they have started working, incorporating this root fractures identification, feeding the root fractures also into the data. Okay, training data. So the training data also requires a lot of time and lot of dental experts. Okay, and here whether there is caries or there's no caries, based on the inputs it will detect. So what DiagnoCAD? What a DiagnoCAD do? It just calculates 122 attributes of the teeth, or the structures of the jaw and teeth, and then right from normal filling, crown, presence of caries, no caries, and pulp canals. And each image each tooth is being analyzed, and a report will be generated, and it can be sent to the mail or saved to the informative system. And this is a flow diagram of processing, this CPCT processing pipeline and workflow of AI system. This Diagnocat conducted a study based on, it considered 5 modules. One is, so based on module, again, it depends upon, mainly based, the data we feed every time will be the same, but it is the software which detects it. So again, the software is again dependent on the type of the data that initially it has been fed as a training sets. Okay, training sets and testing sets. So CPCT volume 5, these things, 5 modules. One is a region of interest localization module. The second one is a tooth localization module. Next, caries localization module, and periodontitis modules, and periapical lesion localization module. But that means if this is there in the training data and the software, what all we need to expect, what outcome we should expect is whether these modules are being tested correctly or not. Because we, the dental experts, we know that we will apply the common sense and logic behind it. So when they applied these things, and the DICOM image has been fed to the software, then the time here it is rightly identified the presence of caries. Again, caries being visualized in the red. The reason for being is it's a sign of sacrifice. The caries lesion localization mask at the sagittal size slice of 1/7. Same software, same CBCT scan. Here, this has not been masked by the software, okay, or the computer system. Here lies incorrect classification of the caries lesion by the software. There lies the human mind, okay, abstract thinking, whatever. As here, it has not been masked, maybe because of the artifact, metallic artifact, which is so this type of things also may happen. So you have to take this also into consideration. And convolutional neural networks are the most commonly used for object localization and segmentation. And these convolutional neural networks, there are studies, a few studies, and stated that the convolutional neural networks detected the periapical lesions, root fractures, periodontal disease, cystic lesions, caries detection, staging of lower third molar development, and tooth detection and other pathologies. Here, again, as I was discussing, it's the software which matters. Again, these softwares also, most of the studies that I'm quoting here, like the features, apical lesions, root fractures, they did this, reported the studies stated that they have done this. They have made their own software algorithms, conventionally made, maybe 7 layers of the neural networks, and they did it for 10 times, 10 to 12 times, repeated exposure of the data to the software. They have done in that way. So for these things, we may not have a licensed software to detect these lesions every time, everywhere. Thus, AI provides an added value and decision support tool in the dentistry. These are still in the studies, at the studies level. And a role of AI in aesthetic, prosthetic, and restorative dentistry. In order to provide the ideal aesthetic process for patients, various factors like facial measurements, ethnicity, and patient preferences has been integrated by the design assistant called Rapid. This Rapid integrates the computer-aided design, that is CAD, knowledge-based systems and databases, employing a logic-based representation as unifying medium. AI can also help to orient and score, automatically mark the preparation margin before sending to the dental lab. So here you have a CAD/CAM system. The CAD/CAM systems, especially in India, they're using, one is Exocad and the second one is the C-Shape, and there are a few others. Here, how does CAD/CAM makes our job simple? You have 6 tasks here. One is tooth preparation. You need to have a tooth preparation. Later on, the intraoral scanning and to obtain the 3D images and 3D images. Again, it has been sent for the restoration design and along with the software. Then after the designing the final restoration with 3D image and the software, you go for milling, and milling machine takes the design and shapes the crown, veneer, inlay or onlay bridge from a single block of the ceramic or even the zirconia or titanium, or maybe the okay. And later on, sintering and polishing can be done before the polishing. It has to be stained or glazed to have a natural look, and later it is being cemented. So how many steps if we are foregoing with this? May it be the restoration like a crown preparation, may it be inlay, onlay, veneers, or bridges, or dentures, implant supported dentures. Here, tooth preparation is the same for us, but intraoral scanning, otherwise you may have to take conventional impressions. No? Then you have to have a sending it to the lab. And my lab also, it takes a lot of time. Here you can save your time, and there are hidden costs like transportation, and also it is also saving the cost. Okay. And the advantages for this being a single visit treatment. The treatment is expected to be completed in 45 minutes to 2 hours. And digital impressions. A scanner is placed in patient's mouth like a digital impression and moved around the affected area. And cost effectiveness. CAD/CAM technology eliminates several outsourcing costs. And AI in endodontics. Usually to evaluate for more than one canal, we may have to go for the CBCT. But due to its high radiation dose, AI has been introduced to classify the given data to determine whether the distal root of the first molar has one or more extra canals. Okay, this is a
integrated with practice management software. How amazing that is.
See here. See here, with this naked, with our eye, human eye, we are not able to appreciate whether there is a cavity or not. But the AI software detected that there is a caries or a demineralization is there. So when it is being measured, how much would is it demineralized? Yes, there is a here you have a 9% of decalcification, and here 12% of decalcification. Finally, it's you people, we people who has to decide whether to go for intervention or treating this decalcified lesion or not. Again, it depends upon the retention and stability of that, whether the are we going to do justice by treating here this tooth based on this area to be isolated. Again, these are the things that we need to decide. Okay. Next, coming to artificial intelligence in orthodontics. The diagnosis and treatment planning can be done by analysis of photographs and radiographs by intraoral scanners and cameras, which eliminates the necessity for making patient impressions and other laboratory steps, and the results are usually much more accurate. Artificial neural networks are used to help determine the need for tooth extraction before orthodontic therapy, and also in patients with malocclusion. Tooth movement and final treatment outcome can be predicted by using algorithms and statistical analysis. Is a CPCT analysis where the software measured the diagnocat and right and left sides of the SF has been an SF analysis done to evaluate the symmetry of the face. Okay, this is analysis, and here lies the abstract thinking of a human being. See here, we are uploading. How you need to analyze this, you have to upload or import the image into that particular software and wait for the input that has to be reported. Okay, so when we have upload, we have to upload the right image. Here, this is a analysis NemoCef. For the CEF analysis, we, like one of our PG student is doing, and where suppose wantedly we uploaded this image, this intraoral picture into the lateral CEF mode. Okay, then let us see what happens. Select the image and put it here. And the machine asks for the image calibration of the image, and we have calibrated and selected the type of analysis, selecting the type of analysis, that is Steiner's analysis, and click perform the tracing. See here, the tracing is being done even onto this with this image, the intraoral image. So this is what the machine does. And this is what the humans want. Okay. So it has generated a report also. See here. Okay. So there lies the human mind. Next, this is another one. The same patient. Suppose CEF. CEF we are uploading in the panoramic as well. There also it has started doing calibrations, but we have to rigorously do it. So when we are uploading, asking for the calibration, then perform the tracings. Here, the AI is partially AI based. NemoCef is partially AI based. Select the analysis, Steiner's, do the calibrations, and automatically it is giving see the report generated by the NemoCef. So coming to the AI, role of AI in periodontics, there were studies where the AI, artificial neural network, effectively categorized the patients into aggressive periodontitis and chronic periodontitis based on their immune response profile, and they can perform the image classification and segmentation on radiographic images of periodontally compromised tooth. By determining the stage of the disease is being done based on the identified patterns and the performed edge detection. Okay. See.
Radiographs and panels, and we're also going to take a look at AI.
Yeah. Artificial intelligence in oral and maxillofacial surgery, it is the robotics. It contributed to oral surgery through development of robotic surgery, where human body motion and human intelligence is simulated. The successful clinical applications include image-guided oral implant placements, removal of the tumor and foreign bodies, and biopsy and TMJ surgeries. It aids in achieving the shorter operation time and safer manipulation around the delicate structures, and higher intraoperative accuracy has been reported. And robotic assisted dental surgery, YOMI is the first FDA cleared robotic device guidance system for dental surgery, and it provides dynamic planning software that can be changed anytime, and real-time visual guidance will be provided along with the physical guidance. And patient tracking, intraoperative tracking maintains the accuracy throughout the surgery. This is another video robotic surgery downloaded from the net. So this is all about the robotic surgery. And beside all these applications of AI, the most prevalent and easy to understand is our dental chair, which a dentist uses all day for his patients. AI has drastically changed the dental chair from conventional hydraulic chair to electrical chairs and fully automated dental chairs operated through sensors, as some of us have been going through and using it. The recent and additional advancement is voice command operated dental chairs, which needs no physical efforts from the dentist. That future is not very far, when a dental chair can calculate the patient's weight, vital signs, and anxiety as patient sits on a dental chair for treatment. What are the future perspectives? So far, these are some of the applications that I could make it out. And what are the future perspectives of AI? AI systems must apply to real world situations and be designed for clinical evaluation and deployment. Due to the need for precision and instant information exchange in dentistry, AI will continue to connect the dental profession in every aspect, and deep learning will help the researchers of better understanding the multifactorial diseases will be possible to improve the collective knowledge of oral diseases or conditions that are currently not fully understood. In future, the dental clinics will establish an AI comprehensive care system with improved ergonomics. Before each appointment, a patient history analyzer will evaluate the planned treatment with patient's gender, age, vital signs, medical history, and current medications. The dental history will be recognized from as a series of digital 3D images and radiographs. During the appointment, proposed diagnosis will be generated by AI problem detector, and recommendations for the treatment will be provided. The future AI dental assistant will be able to analyze all available information about the patient and potentially read the relevant radiographs using pre-trained algorithms. Nevertheless, AI will not replace the clinician's role, but will assist the dental practitioner in adapting an upgraded version of dental practice and management. The role of AI will enable various interdisciplinary treatment proposals in treatment planning, and with benefit and possible complications based on the collected evidence. With the current trend towards the CAD/CAM, with certain materials requiring the higher level of precision in prosthodontics, elaborately designing software incorporated with the AI capability will be in high demand. Dental implant therapy will be standardized using research based on clinically proven techniques. Once the CBCT scan and intraoral scans are taken, the AI will automatically merge the two scans together and suggest the design of future restoration and place the correct implant with proper design and ideal position based on the tissue thickness, bone type, and the patient's medical history. Dental institutes and clinics will have the opportunity to build their patient library with the AI in future. Same case with the implant library, and enormous data mining is possible with the artificial intelligence in future. So to counter the unreported data, opens additional avenues for research to vast data, including the electronic health records, digital radiographs, and longitudinal follow-up data. This will also be possible to establish a reliable source for training the AI system. So that is one more thing of concern. The AI algorithms also to be trained periodically and repeatedly with as large data as possible. The use of AI by dental insurance will further develop and ultimately allow for immediate claim approvals, though it is not currently applicable in India. The AI technology will learn patients' preferences to allow for overall better experience, may it be related to the temperature, may it be related to the kind of music and the amount of light that the patient prefers, and which day the patient is comfortable and what is the time in the day that he is comfortable, and to which doctor the patient should get be comfortably treated with. By improving the experience of patients, more patients will have proper health care and therefore better systemic health. What are the advantages or merits of the AI? It is not biased and only consider the data that is provided. There are no human emotions with AI. There's no fatigue and tireless performance of the tasks within no time. Performs the task in almost no time, and procedures can be standardized and the logical and feasible decisions without any involvement in human emotions, and they don't get bored. Demerits or limitations of the AI is complexity of the mechanism, the cost effectiveness, these costlier setups, and the adequate training is required, and a lot of data is required. Data is often used both for training and testing and leading to data snooping bias. So if you just see, it's all like sample size. If you use only small sample size, 10 cases, and you draw conclusions, it is not all. If you use 100 cases, you use a sample is 100, then whatever the prediction or observations are more reliable. Same thing happens even with AI. So the outcomes of the AI in dentistry are not readily applicable, and enormous data is required for training and precision, and it is difficult to achieve accuracy in rare conditions or diseases. And questionable accuracy is there, and cybersecurity is also a concern, threat. So with this, I would like to conclude by saying that there is tremendous potential for research in artificial intelligence in dentistry. Research should be integrated with the clinical practice for better results, and the incorporation of these techniques will not only enhance the efficiency of the specialists, but also help in better patient care. Artificial intelligence can certainly be a tool in making significant progress in delivering the better healthcare to the patient, but also, but in no way can replace the human knowledge, skills, and power of judgment. So the take-home message would be to think of AI as a tool for making better use of the data in research and patient management. Check whether the infrastructure of your clinic or practice is in place for the integration of AI into your workflow. Data protection by software providers should be evaluated, and be confident of the human strengths like creativity, abstract thinking, and uncertainty, so that hence the AI can never overpower the human strengths, because you have created the AI. Okay, so though it can act as a double-edged knife, use it carefully. Okay, these are some of my references. And finally, the technology and people do not have to compete. Collaborating with AI, we can augment and amplify many aspects of work and life. with this, I would like to thank all the patient listeners, and my sincere thanks would also go to Indian Academy of Oral Medicine and Radiology, Dr. Vinay Kumar Reddy sir, Dr. Prashant Shenoy sir, and Dr. N.K. Sunil sir, Professor and Head Department of Oral Medicine and Radiology, Tirthankar Mahavir Dental College and Research Center. Wish you all the success and bright future. Thank you one and all.
Thank you, ma'am. It's a really very informative and educative lecture. And you have been briefly narrated about the machine learning, deep learning, and you explained about the various softwares in detail. And you showed some videos. Really, it is amazing. And definitely, I think the people who are there in the UG students and the PG students, definitely they are definitely benefited about that. And they might have a glance of what is artificial intelligence and their future perspectives and their uses in that. Anyone have any queries, please kindly unmute yourself and then you can ask a question. Ma'am, can you stop share screen? Hello? Any questions? I think it's a crystal clear presentation, and hello. Ma'am, kindly accept our virtual certificate of appreciation to you. And thank you very much, ma'am, for accepting our invitation. And you definitely explained and narrated about the subject in a very detail. And definitely everyone has been understand the things. And at the last, I thank my principal, sir, for giving an opportunity to associate with the IMR program in this nationalized online CD program participated by many states and many delegates. And secondly, thanks to our Tirthankar Mayanus, our chairman, sir, and the vice chairman, sir, and vice chancellor, and registrar, and other dignitaries who has been given a backbone support in organizing this program. And special thanks to my close friend, Dr. Vinay Kumar Reddy, the president of IOMR, as well as the secretary, Dr. Prashant Shenoy, and Dr. Deepthi Bhatnagar, treasurer of IOMR, who has been another office bearers who supported in organizing this event. And lastly, I thank to my faculty, Dr. Upender, Dr. Garima, Dr. Anjali, and Dr. Shilpi, who has been supported me in organizing this online CD program. And also my postgraduate students, definitely, and they are the backbone, and they supported me a lot in organizing this. And thank you all the delegates who have shown the interest and participated and made this this particular event successful. I thank you all the delegates. If I miss anyone, kindly consider. And thank you everyone for your valuable time, and hope you have a fruitful knowledge about the artificial intelligence. Thank you one and all.
Thank you, sir. Thank you.
Thank you, ma'am. Thank you for that. Thank you for support.
If there are any queries, they can mail me, sir.
Yeah, definitely, ma'am. Definitely.